Right, mock exam paper 2020, question 6. The elevation and ground floor plan of a house are shown. The house also has 2 bedrooms and a bathroom upstairs. The external walls are of timber frame construction with an external rain screen of native larch. The house is designed to have a low environmental impact. With reference to the design shown, discuss using notes and freehand sketches 3 features of the design that contribute to the house having a low environmental impact. Okay, so I'm going to maybe approach this one slightly different to what I've been doing. I'm going to have a look here at the marking scheme and walk down through the marking scheme and see maybe what you think of that. And it might be more beneficial to have all the answers here like this, and we walk down through them and talk through them. Let me know if you think it's not working great. We'll go back and we'll maybe sketch out a bit more and stuff. We'll see how we go. Okay, I suppose the big thing to note here is, again, it says notes and sketches, okay? Now, looking down along through here, the sketches are very basic, okay? This is what I'm trying to get across to you. You need to put in sketches. Make sure you're putting in sketches of some sort here. Because like these seem very basic across for most part of here. So some sketch, any sort of sketch, as I said, put them in as best you can, but make sure they're there, okay? So with reference to freehand sketches, features that features of the design that contribute to the house having a low environmental impact. Well, the first one is the glazing, the orientation. So we've got large areas of high performance windows on the south elevation to allow for maximum solar gain. Again, we're back to talking the same thing again. Windows on the south, maximum solar gain. Fewer and smaller windows on the north elevation, reduce heat loss. West facing windows allow evening sunlight to the living area. Less heating required as solar gain is maximized. Solar efficiency, long elevation on the east-west axis, designed to maximize solar gain and thermal comfort. Okay, so we've got on the sides here, we've got large areas here. Designed to maximize solar gain and thermal comfort. High thermal performance units, e.g. frames with thermal brakes and triple glazed argon gas filled low soft coated glazing. The area of the orientation of the frustration support the use of passive solar gain to complement space heating. High thermal mass materials on floor to retain heat and release slowly. Okay, so got our high thermal mass? We got our concrete floors because it retains heat. Passive heating reduces costs and demand for scarce and expensive fossil fuels, etc. Okay, so there all are possible things we can talk about for glazing. So while these are appropriate for maybe this question, anything that comes up about glazing, we can talk about this. This house here also has roof lights. So roof lights provide about 3 times more daylight over a longer period than dormers. Reduced need for artificial light, obviously because we got more light coming in through the roof. Reduced demand for fossil fuels and reduced lighting costs. No shading unobstructed light for longer. Okay, no unobstructed light for longer. So we get more light in there and we get it in there longer because the sun can get in there longer during the day. That's the evening time. Chimney fireplace. The chimney stack on the internal wall radiates stored heat to adjoining spaces. Positioning of solid fuel heater and flue on the internal wall optimizes the conservation of heat within the house. Wood burning stoves are carbon neutral. Okay, so obviously if they're burning wood, that's a renewable source of material. Stoves are up to 70% efficient. Open fires are at best 30% efficient. They can heat radiators throughout the house, and the wood burning stove to maximize efficiency. Okay, so that's maximize. So we're getting the most out of using that stove. Okay. We got a steep pitch roof, allows for bedrooms and bathroom, which is economical in terms of space and materials required. So we're not building big massive houses to get up to the top to accommodate these. We're actually creating quite small, low houses, but still getting 2 stories. 1 compact foundation, 2 floors and roof space. Reduce costs and energy requirements. small footprint with the attic space used, enables maximum use of the attic as a habitable space, less materials as form is compact, lower embodied energy, lower CO2, solar panels fitted at an optimal angle of 45 degrees, roof used to collect solar energy, etc. Okay, and add the other appropriate answers. Open plan design. So what's good about an open plan design? Well, reduce materials in construction, because we're not building walls. Allows direct sunlight into the entire building, so walls don't block out sunlight passing through. Frequently used rooms on southern elevations, so our rooms that we're going to use most, like our living room and our kitchen, on the south of the house. Doors can be fitted to reduce open plan layout, making it easier to heat. We've got small internal spans to allow for ease of redesign, so if we want to change the house, and lower costs of standard materials. The compactness of the design reduces the volume of air for space heating. Okay, so the house is real tight, so there's less space inside it that we have to heat up. Timber frame. Okay, so it's the timber frame construction. The high level of insulation provided by the timber frame construction reduces energy use for the space heating, thus reducing the use of fossil fuels. Timber reduces use of concrete. Concrete is a high embodied energy, reduces CO2, damage to the environment. So what's a high embodied energy? It takes a lot of energy to make it, okay? So concrete has to go through a rigorous amount of process to make cement, whereas timber obviously grows and it's quite easy just to cut up into logs that we need to size. Much less energy is required to process materials like wood as compared to cement, which requires large amounts of energy to manufacture, just we said there. Using materials that are renewable, that grow and replenish, that are capable of being harvested between 25 and 40 years from managed forests, ensure that there will be an ample supply of building materials for future generations. Okay, so when we cut down trees, we replant them to get more. Renewable materials have a smaller impact on the environment. Locally grown timber has a less embodied energy and reduced transport costs. Some timbers are more naturally durable, e.g. European larch, Douglas fir, cedar do not require treatment with chemical preservatives because they've got a natural preservative inside them. Less fossil fuels are used during the production of renewable materials. Again, here, just limited use of concrete. Concrete made from Portland cement has a high embodied energy. We know what high embodied energy is. Portland cement produces 90 kgs of CO2 emissions for 100 kilograms, so that's a ton of cement. Ground granulated blast furnace slag is manufactured from a waste product produced by the steel industry, recycling, upcycling. Concrete made from GGBS has a low embodied energy. Low carbon concrete uses 50% normal Portland cement and 50% GGBS, which reduces the CO2 emissions by almost 40%. While GGBS is important in Ireland, the embodied value is still considerably low compared to the required to extract raw material from the landscape and its subsequently manufacturing costs. Concrete or concrete products should be ideally manufactured using low carbon concrete. So that's your it's all your eco-friendly cement, which is actually, they say, is nearly actually better than your actual original cement. It actually hardens better over time. Lack of outside concrete footpaths, walls, concrete significantly reduced. Okay, so obviously if there's less concrete footpaths outside, there's less cement used, which means there's less embodied energy. Larch cladding. So the native larch finish on the exterior is carbon neutral and reduces the embodied energy of the house given a low carbon construction. Larch cladding is naturally durable and needs no preservatives, can be flamed, charred as a finish. The use of wood and other organic materials reduces carbon emissions and acts as a carbon store over the life of the building. Wall can be built to any specific width, allowing higher levels of thermal insulation, reduced heat loss and faster heat up time. It advises the use of chemical-based plasters on the external wall. It can help reduce noise from the outside. An increased range of wall finishes available, stains and preservatives. A sustainable material that can be sourced locally, so lower transportation costs. Can be added after the building to improve performance and can easily be repaired and replaced when necessary. Natural weathering will allow the building to blend into its surroundings, etc. Okay, and a general one. An overall height of the house makes it less obstructive in landscape. The external surface area is reduced due to the two-story form. Many renewable materials are carbon neutral. Okay, so if you have a look there, there's obviously a lot of information in that there, and you wouldn't be expected to produce every single point there, but a lot of those are overlapping in what we said already in other questions. And the sketches, quick sketches, we just got a quick sketch of a timber frame construction here. Even a 2D one you would do, yeah. Again, just the layout here, they're very small sketches, but they're very important to put in because they're equal to the same amount of marks as you do have writing. Okay, part B of the questions. Low operating costs are important considerations when designing new eco-friendly homes. Using notes and freehand sketches, describe 2 other design features that could be included to further reduce the operating costs of the house. Well, I'm just looking here. We don't have an MHRV by the looks of it. We don't seem to have solar panels. There's no... What else is there? We could have renewable energy. Wind turbines, maybe. Solar cells. Yeah, that's what I think I've had. Have to look here now. Okay. So, possible answers here for this. So, again, we've got notes 5, sketches 5. So that's they're equal to marks. So adding to the building fabric, storm porch to be constructed at the entrance to prevent direct access and reduced heat loss. Second external door to be fitted to the rear hallway to form storm lobby. Internal doors fitted to zone sitting room from kitchen, dining room. Increased size of windows and roof lights. Windows on southern face, increased solar gain. Okay, they're all things we can do to add to the building. And if you were doing them, you just put in a sketch. So if you're drawing in a porch, you put on the porch on the back and put in a sketch of it. 2 here is install evacuated tubes. Okay. Evacuated tubes to be fitted to the front roof, southern elevation to provide up to 6% of hot water requirements. Less electricity required, thus reducing operating costs. Okay, so we can put in a tube. Install photovoltaic panels to generate on-site renewable energy. So PV panels to be fitted on the front south roof, which converts solar energy, sunlight into electrical energy. PV panels can be used to supplement electricity supplied from the grid. PV panels reduce the use of mains electricity by replacing some of the mains power with electricity from renewable sources. Average annual consumption of electricity per household is about 3.3 to 4.7 kilowatts. An area of 21 meters squared on a photovoltaic photovoltaic panels produces about 3.12 kilowatts of electricity. Lithium-ion batteries are being developed to store electricity generated by photovoltaic panels. Tesla Powerwall home batteries, which store enough energy to allow a household to go off the grid. Okay, so you can go off and you don't have to pay for electricity. We got wind generator to generate electricity from the winds, or wind turbine. So wind speed and height of the turbine are critical for electricity generation. A turbine should be a minimum of 10 meters above the roof or any other structure within 100 meters, such as buildings or trees. To reduce turbulence, which reduces efficiency and causes undue wear, microturbines generate very little electricity. A few hundred watts are used on caravans and are not suitable for supplying power to a dwelling house. A microturbine between 1.5 meters and 2 meters in diameter may provide about 10% of the average power use of a house. That's 4,700 kilowatts per hour per year. Turbines vary in size and power output from 1.5 meters to 2.5 meters in diameter, suitable for a single dwelling, ranging from 5 or 6 kilowatt turbines to 2 to 3 megawatts for community-owned turbines. Most small wind turbines generate direct current, so DC electricity. Off-grid systems require battery, storage, and an inverter to convert DC electricity to AC, which is alternating current, as used for mains electricity. A controller is required to ensure the batteries are not over or undercharged. Battery storage not required if connected to the grid. So what happens if you have that connected back to the grid? any excess electricity made goes back into the grid, and then you can get a refund back off of whoever your supplier is. So Bor Energy Ireland or ESB, they'll pay you to make electricity. Now, the amount that you'd actually reduce would be very little to send back, but if you're connected up, you can sometimes just get a discount off your bill. Rainwater harvesting then, so collect rainwater from the roof and stored in containers for reuse. Inexpensive rainwater butts can be placed at downpipe, water used for watering plants, etc. Rainwater can also be collected and stored in a larger capacity tank, usually placed underground in the rear garden. Water is filtered and pumped into the house to be used for flushing toilet and watering flowers, and any other one is acceptable then. And again, just looking here at the sketches, they're very simple sketches, just some sort of thing to explain what you're doing. Part C, discuss in detail 2 advantages of local materials when building an eco-friendly house. Well, obviously the transport, there's going to be a reduced amount of energy used to transport the materials. It's going to be more eco-friendly in the environment. It's going to blend into the environment more. So what do we got here? What's given us here is this one. Locally sourced materials allow building to blend in with surroundings. Reduce transport costs leading to reduction in CO2 emissions. Select materials with low maintenance requirements. Naturally grown sustainable materials reduce negative impact on the environment. Timber from managed forestry is highly versatile material. Reduce use of concrete by careful consideration of alternative materials. Local materials worked on by local craftsmen ensure local building traditions are passed on to next generation. Economic benefits to local community resulting from a high levels of spend by local craftsmen. Increased knowledge of locally on importance and of low energy building, and embedded on a culture of environmental awareness among the community. Okay, so again, a lot of these are all very similar. They're all very much the same question, just asked in a different way. Alright.